Hello everyone and welcome back to another video. This time we are going to look at creating an Oats environment, development environment. And for this video and the videos that will follow, we're going to start building with Oats. I'll assume that you are familiar with Node, NPM, and just the basics of web development, which is HTML, CSS, and a little bit of JavaScript. And for this particular setup, there's a bit of Webpack that will do, but you don't need to know Webpack. Actually, to build with Oats for most of the bits, you don't need to know Webpack, but it's highly recommended that you know Webpack, how it works, so that you can leverage it and use it to make your web development experience much better while using Oats. But with the best setup that you get with Oats, everything should work just fine. Now, I'd already written about this, so I'll provide the link to the article in the description. But this video will just go through the article and actually do the setup in a live environment, quote unquote, so that you can easily follow along and get to know how to set up an Oats project. And then now we can continue with the rest of the tutorial series that will follow. Now, there are two ways that you can set up an Oats project or development environment. The first method is using the Oats CLI, which is recommended because this is a really easy and fast way of setting up your Oats environment. You just need 2 commands, and that's it. You have everything set up. And the second method is through a manual setup that involves installing each dependency manually. That will take a long while, but it's something that we want to do if you already have an existing project that you'd like to convert into an Oats project. Now, let's start with the first method using the CLI. Now, what you'll do is you'll navigate to the folder that you want to set up your Oats project. In my case, it's the CLI. I've called that folder the CLI setup folder, and then you'll open a new terminal. And it's at that terminal with type npx Oats CLI. Now pay close attention to the spelling and the hyphens. And then now when I hit enter, being asked whether I want to install the Oats CLI package, I'll press Y to proceed. And then now finally the CLI kicks in, and you can see the message that the CLI will set up an Oats app for you in your current directory, and my directory is listed there. So confirm to proceed. I'm going to confirm with the Y. Now first it transfers files to my folder, and then finally it installs dependencies. All dependencies that you need Oats and any other thing that and Webpack mostly, and its loaders. We'll wait for that to complete. And now when all dependencies have been installed, you can see that you get a message that we have successfully set up an Oats app at our directory. So with that done, we can just look at what was loaded. So this node modules just folder came automatically after we started installing our packages, but what specifically came from the Oats CLI was this proxy server. I'll explain that later. The source folder, which is our app folder, and here we have 2 fragments about home, and we have index, basically where we write the starter code for our app, or the startup code. And then you have server, where we have our server views. And then we have Webpack configs, where we have specific Webpack configurations for our project. We have the Oats configuration, where we have the default configuration and a main configuration. And then you have our JS config, the JSON file, which contains some directives that you need so that you can get correct typing for when you're using Oats in your development environment. And then you have package.json, where now we have all our dependencies listed. And you can see that despite loading a couple of dependencies, our main project dependency is OTC. The, mm, the bigger bulk of the dependencies that we're installing are actually development dependencies. So this won't be carried over to your production build. This will just be used in the development environment. Now, the good thing about the OTC CLI is that it already comes with the starter project setup already, which you can run using npm, using the command npm run dev. When we do that, we're going to allow Node.js to access. Now, the starter project is built and we can access it through either localhost 8080 or this address provided. And I'm just going to navigate to my browser. Just go to localhost. And there you go. This is the starter app in the CLI. You're actually running Oats right now, and you can see our homepage, and you can navigate to about, which loads the about fragment, and you have more information that is provided here. And you can go to home, you can go to about, you can use the arrow navigations, and the app still works. So there you go. You have a good startup project to look at. And once you've done this setup, the only thing that you have to do now afterwards, you can just stop this. Now, the only thing that you have to do afterwards is just edit your files at source and add in your new fragments, delete the ones that come with the startup project, and you can just start developing your OT web app. Now, the other method that we have is the manual method. And what you're going to do now is to look at how you can manually set up an OTC project. It's going to take way longer than the CLI method. But remember, this is something that you might have to do if you have a project set up already, and now you want to convert it into an OTC project or web app. Now, for manual installation, you're going to work with a new folder. So just come to the Explorer and just set up a new folder inside here with manual installation. Now, of course, don't put your folder inside folder where you did your CLI setup. This is just for demonstration purposes. In my terminal, I'm going to navigate there. Now, the first thing that we're going to do is to set up a package.json file. So we're going to do an npm init file. Here you can see we have a package.json file. And then now what we'll do next is that we'll install OTC, which will install the core OTC library. And to do that, just do npm install OTC, use a hyphen, and it's already, and we have OTC already installed. That was very fast. And then now what follows, because OTC is your main dependency, what now follows is the Webpack configuration with the Webpack setup. We're going to install the Webpack dependencies, and then we'll configure Webpack, and then now we'll have our project set up and ready. So the first thing that we'll do is to install Webpack. And so we're going to run the command npm. We'll save this as a development dependency, Webpack, the Webpack CLI. Oh, sorry, I didn't specify the Webpack CLI quite well. It needs a hyphen. So I'm going to redo that command. There we go. Now, the next thing that we're going to install is the Webpack Dev Server. What we use the Webpack Dev Server for is to provide a development server that automatically looks for changes in our files as we're writing our code and refreshes our browser so that you always see an updated version of the app. So you don't always have to hit refresh as you're making changes and looking at them. So we're going to just use this code. Actually, I'm just going to copy it direct as I have it here. And I'll paste it there. Also installing that as a development dependency. And now that you have Webpack and Webpack Dev Server installed, now we're going to start installing the loaders that you're going to need. Loaders basically, as far as Webpack is concerned, are let me call them modules or utilities that allow Webpack to be able to bundle bits of your project and provide the final distribution files that are going to be used to actually run your project on the browser. That's what the server will give out, and then you'll be able to run our projects on the server, on the client, I mean. And also, they help in resolving certain file types or allow you to use certain utilities that just make the development much easier. So in our instance, we're going to install Handlebars Loader. So what the Handlebars Loader does is that it allows us to use the Handlebars templating engine to write our views, which is a much better way of providing views, because you can be able to bind your views to data and allow your views to be dynamic, sort of. And so we're going just to copy this command, and we're going to save it as a development dependency. And there we go, we have Handlebars Loader in. And then now we install the HTML loader. The HTML loader will allow us to, in conjunction with the HTML Webpack plugin, which is the next one that we'll install, it will allow us to produce our server HTML files, which now will be rendered or passed to the client from the server, and will allow our web page to load with a specific view from the server. Now, we're going to install HTML loader first. And then we're going to install HTML Webpack plugin. All this again are still development dependencies. The only main dependency that you need is Oats. Then I'll just come back here and now install our Babel loader. We're just going to have a very basic configuration for the Babel loader, but the Babel loader just allows you to do a lot of transformations and very other cool things with your JavaScript files, like you can minify them and just do a lot of things. And with Oats, you can always update these configurations and change them to whatever it is that you need, and it won't affect the core working of your web app. Now we'll finally install the style loader and the CSS loader, and this allows Webpack to pack our style files or CSS files into our final HTML file that is outputted with the HTML Webpack plugin, so that you can have styling in our final distribution or production, quote-unquote, files. But when you're developing, we'll be able to just put them in the folder structure that makes sense for our project. And that's the biggest advantage of having Webpack. Now, we've installed style loader. We're now going to install CSS loader. And then the next thing that we're going to install is Webpack merge. Now, if we can just touch a little bit on Webpack. Webpack allows us to have a development environment or a development structure that makes the most sense for our project. So we can structure files differently. We can use specific assets, or maybe even syntaxes, or like in the case of our views, templating engines, instead of writing our views in HTML, we write it in a different format. But then Webpack uses its combination of loaders and plugins to just transform these files and utilities into an output that the browser will understand the moment it gets the files from the server. Now, we're going to install Webpack Merge, and Webpack Merge, we use that for merging configuration files, which is going to be very important in Oats, because Oats has its own configuration files, and we'd like to give you the option to also set up your own configuration so that you can merge with Oats' configuration and have your project outputted by Webpack in the way that you want it. So I'm going to install Webpack Merge as a development dependency, and then now we're going to install Express handlebars, and I'll explain the reason why we have to do this is we're going to run a proxy server. It's not a must that you run it, but you're going to run it for several reasons that will be clear when you're doing the tutorials. And because our files in Oats, we use handlebars for templating, and even for our server files, instead of outputting HTML from the HTML Webpack plugin, we output a HBS file, which is a handlebars template file. We're going to use Express handlebars in our proxy server to mimic how the main server will be rendering the final view that will be sent to the browser or the client. Now, to do that, you're going to need Express handlebars, which now allows us to use handlebars in a Node.js environment, which is the environment that we're going to use for our proxy server. Now you're going to come here, we've copied the command, and you're going to install Express handlebars as a development dependency. Now, that's basically all the dependencies that you have to install. Now, the next thing we're going to do is that you're going to create Webpack configuration files. And these files will basically tell Webpack how we'd like our code to be bundled, the loaders it's supposed to use, for it to create the final output that will be in our distribution folder, or the desired folder that you want the final output for your project to be in. Now, for our configuration file, we're going to go to the root of our project directory, and we'll create a new folder called Webpack configs. So we'll just copy this name so that you make sure you don't have any typos along the way. And then now, in our root folder, we're going to create a new folder and call it Webpack configs. Now, right here, we're going to create two new folders, and you're going to call it main, call one main, and call the other one Oats. So come back here, Webpack configs, create main. I'm going to create Oats. Let me check whether I need a, yeah, Oats is the small O. So we're now going to navigate into Oats folder, and then you're going to create two more folders, and you're going to name one default and the other one main. Now we're going to say Oats, can create one called defaults, create another folder, we're going to call it main. Now, the default folder will hold the default Webpack configuration that Oats needs to have its Webpack dependent functions work. Now, Oats uses just one bit of Webpack at its core that makes this configuration necessary, and that is code splitting and lazy loading. And that's because if there's a fragment builder that you use when you want your fragment to be lazy loaded by Oats, and therefore have it provided to the client or your web app on demand. And because that's something that we need, we're going to have a special Webpack configuration put in this default folder that must always accompany any Oats project, especially if you're going to use code splitting or lazy loading. Now, inside the default folder, we're going to create a file, call it webpack.config.js, and this is basically how you typically name a Webpack configuration file. And inside that file, we're going to put the following code. So instead of just typing it, for the sake of time, I'm just going to copy what is there in the article. I'm going to paste it right here. And I'll just run through what this configuration means. It's just that if you look here, we have these split chunks. Let me call it a directive, which basically tells Webpack how we're supposed to split our chunks and how it's supposed to handle a sync to create a sync or async chunks that's going to they are going to be used within Oats. So basically, whenever you're going to use code splitting or lazy loading, this is the directive that Webpack will look at and determine how it's going to split those chunks. Now, if you're familiar with Webpack, obviously you're free to modify this to however you want it, but this is the best Oats. This is the configuration, the base configuration that Oats provides. So we're going to save this file with that directive of our configuration, and then we're going to navigate back to the Oats folder, get into the main folder, and create a new webpack.config.js file. So I'm going to come here inside main, create another webpack.config.js file, and here again, we're going to paste this bit of code here. Then I'll explain what that configuration does. Now, this configuration is specifically for loaders. Now, for Oats and in most projects that you're going to do for the web using Oats, you're going to work with several main files. We're going to work with HTML files, we're going to work with HBS files, and we're going to work with JS files, asset files, our images in different formats, and our CSS files. Now, this configuration basically tells Webpack which loaders to use for which files, and that allows Webpack to now actually bundle our project well and produce the right output that you're going to use to finally see our project on the browser. Now, for our HTML files, we have our HTML loader, though the HTML loader also works with sv.hbs files and p.hbs files. And you'll understand the need for these files later on when we'll be looking at server-side rendering. But basically what you can get for now is a sv.hbs file is actually a handlebus file, but a handlebus file that is being used specifically for the server. And if you look at our initial setup that we did using the CLI, if you look at source and server, you can see we have a home.sv.hbs file. This is the file that is rendered at the server, is outputted and rendered at the server, and pushed to the browser when a page is requested. And then you have a normal HBS file that's handled with the handlebars loader. You can remember us installing this as development dependencies. Our JS file that is handled with the bubble loader. And then you have our assets, PNGs, SVGs, JPG, GIF. You can add any more. You can add more assets that you have. The extensions basically is handled by the assets resource loader. It's inbuilt by Webpack, so you didn't have to install this as a dependency specifically for Webpack 5. And then we have our CSS files, which are handled by the style loader and the CSS loader. So basically, this goes hand in hand with what we'll get to the CLI as well. In the main folder inside Oats, you'll find configuration for your loaders. Feel free to modify them in case you want to use different loaders. In our default folder, we'll find configuration for code splitting and lazy loading. If you're familiar with Webpack and you want to modify this, feel free to modify it to whatever suits your project, as long as Oats at the end of the day has this configuration so that code splitting or lazy loading is going to work. Now, we're already done setting up the core Webpack configuration for Oats. Now, what you need to do is to merge them in a common configuration file that you can now use project-wide. And a good reason for doing this is that now in the common configuration file is where you're going to put now our entry, configure our HTML Webpack plugin, and provide its inputs and outputs and all these other things that are now more specific to your project. Everything that you've put in the OTC folder are often more related to OTC than it is to your entire project. Though obviously there are things that you can modify. Now we're going to navigate back into the Webpack configurations folder and inside the main folder, and then we'll create a new Webpack configuration file. So we're going to close this, get inside main, and then we're going to create a Webpack config JS file, and then we're going to paste this code inside here. Save the file. Yes. And now we have our main configuration setup, and I'll just run through it so that you can be able to understand what's happening. Now, because we're going to set up HTML Webpack plugin here, provide its template and file name outputs, we require it here. And then we're going to require a file or a module, call it a module, that's called the dev server middleware config. Now, this is something that I recommend from my own experience, because within development environments, often you don't want to access APIs. Some of them are your own APIs, but they're being developed separately, let's say by the backend team, and you don't want to proxy to the server that you have access to, or the backend team has given you access to, that will give you the best representation of how your front end will be running. Now, using a proxy is good because sometimes you may be dealing with CORS issues, and instead of having to install some plugins to your browsers or have to create configurations for when you'd allow cross-origin requests or when you don't want your server to run cross-origin requests, personally I find the best way to do it is just use a proxy server. So you don't have this weird overlap that will make development a bit painful for both ends. And then here we just specify the path that you're going to output our assets. Remember, I told you what Webpack does is, if you look at the example that you have from the starter project, which you installed using the CLI, we have a source folder. Let me just close this. Don't look at manual installation, ignore it for now. This is the folder that was created, or rather these were the files and the structure that was created with the CLI. And what we have is we have the source folder, and here we had our app, and you had our fragments. If you look at the about fragment, it had its own assets folder, its own scripts folder, its own styles folder. Basically a very unique structure that suits the project. Now, if you just provide this kind of configuration or file structure to your server, would have a couple of issues when trying to output the basic HTML file that you need with the correct head tags, with the script and the styles. Now, what Webpack does is that as I write my code using the unique structure that I need for my project, Webpack bundles these files that I need and then puts them in a dist folder. And now in the public folder, you can see I have my assets. Now all these assets, instead of being in their own bespoke folders and unique file structures, they're now put in this one assets folder. And you have our JS, put it in its own bundle. And then we have our views. Remember our home.sv.hbs file that was here at source and server. This home.sv.hbs file, it's finally been outputted into a home.hbs file. And you can see here at the script, Webpack has been able to automatically inject the right bundle that's going to be used as the script for this HTML file, which represents our home page basically. Now, this constant right here just holds the folder. We're going to put our assets and we use it here. We'll explain shortly. If you're familiar with Webpack, you can just skip to the front. And then here's where we use Webpack merge. And if you look at where exactly now we use it after importing it, the merge function merges our default config for Oats and our default loaders config for Oats. And now our main configuration that we have for our project. And then, yeah, the rest just imports for the default Oats config, the default loaders config. And we already talked about how much does it to merge these three configuration files and export it as one configuration file that now Webpack will use. And then he's just specifying our mode and all these things. What's important for you to know here, if you're not that familiar with Webpack, is here we have our output directive where we specify the path where you want our files to be output, and we're using the public path as the default path, but for our views you'll see that we'll be able to reference our views relative to the public. We'll see that later. And then yeah, we specify how we want our assets to be named, how we want our file name to be named. Our file name basically is how we want our JS bundles to be named. So you can see in the starter project that we did from the CLI, we have, for instance, the index.js, which is what we use. Actually, let's open that configuration so that you can just look at the main configuration for that. For the starter project, this is the main configuration for the starter project, and this is the main configuration that you're setting up. Now, they look the same, but if you can see, we have our entry directive that points to our index.js file, which is this one here, index.js file. Now, this file name directive will tell Webpack to output our JS files in the dist folder public /js/ the name of the entry file, which is index, and then .devbundle.js, and that's where you have this output. And then finally, I've explained what an entry is. Entry is basically like the entry JavaScript files for your project, because Webpack views projects mostly from a JavaScript perspective. Now we have our index.js file, which we've named as index, given it property index, and then we've referenced its location from the source folder. And then now, when you come here to plugins, where remember I told you HTML Webpack plugin is used now to provide the final HTML, or it can even be a HBS or whatever output extension you want for your file. And this is basically the file that now the server will use. And for example, our template is what you have here at server home.home.sv.hbs, which is this file here. There is the template or its input. And then the output will have the file name of, now remember I'm providing this path relative to the public folder. So you come here and then come to views and then home.hbs, which is this file you see here. And then chunks, not HTML Webpack plugin, which of our JS files should be included in the script tag, of which provided index, which is this. And this index, remember, will be resolved to the dev-bundle.js file. And that is why when you come to my dist folder, my home.hbs, you can see this directive right here. Our JS, our index.devbundle.js file has been correctly included in the final HBS output that will be rendered by a server. And so when there are file loads or other HTML loads in the browser, this script would be part of it already. And this script is what basically where Oats starts. We'll look at that later. And then finally, this last directive is just for our dev server, where now we include our own middlewares, which will allow us to put up our proxies, and we'll look at this shortly. Now, basically, I've explained most of the things that you see here. And now what's left, because you can see we have an error, is we have to implement this file right here. Now we're going to save this. And before we do that, because we've set up all of our configs, we're going to update our package.json. Now, the reason we're going to update package.json is that in our CLI setup, when we use the CLI to set up our project, remember when our startup project loaded, we were able to run it using the npm run dev command. Now, we need to set up this command and specify exactly what it needs to do. So we'll come in we'll go back to our root folder. Remember, we're at the manual installation. We're going to come back to our root folder, open package.json, and then here at scripts, put a comma and specify a new script called dev. And this script will run the following command. So just paste this. So what this command will do is that it will invoke the Webpack dev server. Remember, I told you the Webpack dev server is supposed to create a server, a development server, that is going to allow us to run our project and automatically refresh what you're seeing on the browser when any of our files that are associated with the project change. So we're going to invoke Webpack dev server and pass it the configuration that is our main configuration. Remember this configuration that we just set up at main. Is this here Webpack configs main? Remember this configuration? That's what now we're going to give it. And this configuration has matched the default OC configuration, the loaders configuration, and now our project specific configuration. Now, with this directive ready here, we can now run npm run dev, and the Webpack dev server will try to run our Webpack project. But for now, we'll actually encounter a couple of errors because of this. Now let's set up that. Now we're going to set up our dev server middlewares, and for this we're going to go to our root directory, here and then create a new folder. I'm going to call it proxy server. And then inside that folder, we're going to create a new file, call it proxy underscore server.js. And then now inside that file, we're going to paste this bit of code. Now, what this code basically does is that it intercepts Webpack Dev Server as it tries to resolve our roots and provide what the HTML file that is necessary. And in our case, because our output for the HTML Webpack plugin is a HBS file, it means we want to further render this file in our server. And the reason why it's good practice to do this, it's not a must to do this, but the reason why it's good practice, especially if you want to do server-side rendering in Oats, which we'll look at later, is that it now allows you to render your views based on data that you already have from your backend and administer that directly, which means if we have, let's say, like the Google bots or any other SEO bot that is search engine bot that is trying to crawl through your files, when it pings the server, you're able to load it with data already that can help you with SEO. And because Otsy has its own server-side rendering logic, Otsy also, when it loads on its side, you'll be able to understand that this file, if it's actually being rendered on a browser, on a client, it will be able to understand that this view has been server-side rendered. And if you've provided your data manager hydration information, it's also going to understand the data state that has come from the server. But if you don't want to do any of this, it's not a must that you do it. You can just delete this directive and have your files outputted in .html, and that will be fine. And then Webpack Dev Server will just run in default configuration. But in our case, we're just going to intercept it. And what you need to just pay attention to is here, we're going to be rendering only one layout, regardless of the path. And so if someone looks for the home or about page and tries to get it initially from the server, we'll just have this home layout, which is this one right here. This one, we'll just have this layout provided. And then Otsy will just kick in and then look at the specific route and then now render the views or fragments that are needed for that route. Now, this is a good configuration to use if you're not going to use server-side rendering at all. But we just like to experiment with HBS files at the backend. And so you can just render one view, but that one view has your main indexed bundle that starts Otsy. And then for the specific route that this was called for, Otsy will still kick in and render your fragments correctly. So you're just going to save this file. And then this error should no longer be an issue. It will take a while for IntelliSense to detect that, but that should no longer be an issue. Now, the last thing that you're going to do is create a JS-config.json file. Now, what this file is for is that if you're to use Otsy right now, the problem that you'll have is you'll not have, your types will not be inferred correctly. And that means your developer experience is going to be affected a little bit. And the reason why that is happening is because in most packages where IntelliSense in VS Code specifically wants to pick up, you'll have to provide a TypeScript type declaration file for every module that you have. Now, if you wrote your if Oats was written in TypeScript, we wouldn't have any of those issues. But because Oats is written in vanilla JavaScript, and we use TypeScript specifically just for the declaration files and to describe our types, and then combine that with JS docs to provide a full typing system, it means just out of the box, you can experience a few issues with the IntelliSense, specifically in VS Code, because VS Code is my main IDE. Now, what you're going to do for that, to solve that issue, is something very simple. We're just going to create a new file, and we're going to call it JS config.json file. And what this will do is that it will give VS Code a directive on how it can infer types in our project for the scope that you've given it. So I'm just going to copy the code that I provided in the article. And so you can see that the main directive is right here. What it tells it to do is that while looking for type declaration files, specifically those in JS doc format, to look into node modules /OTC. And from there, you'll be able to get your types correctly referenced and make your developer experience a lot better when using OTC. And this is just a development setup. It has nothing to do with the final output that you'll have in production. And that's basically it. When you have to manually install OTC, it's a long process. Hopefully you won't have to do it manually. Kindly just always use the CLI and then edit the files and move on from there. In the article, I dove into creating startup project files. This is not necessary for you for this video. You can just go and read about it in the write-up. And here we're just replicating what you get in the startup project, like to have a startup project that you can look at when you have finally set up an OTC environment. It looks at the server side, like just creating our home.sv.hbs file that we had. It looks at our app files, creating our index file, creating our main nav infos, routing infos, index CSS, JS, and all that. These are not important for this video because you're going to look, the next video that we're going to have, we're going to look at how to start an OTC app, and actually we're going to look at how the startup project has all these files, where we have these specific files in our startup project, the server files, the app files, and then you look at the index.js file, which can just give you a sneak peek. You can also look at it in your setup. Just go to app index, scripts, index.js. These are index.js file. This is basically, if you remember, this is the file that is also included in our final distribution for home.hbs, and this is where the OTC web app starts. We're going to look at that in the next video, and hopefully I'll see you then. If you're interested in this, you want to learn more, there's a lot of content that is in the pipeline. You can hit like, subscribe, and we also have a donation and support link. If you want to support this project and you're interested in what it's doing, well, there are links available for that as well. The code is open source. You can find the links in the description too. You can start the project, fork it, and look at the source code. If you feel there's something you can contribute already, I'll be happy to see what you have. That's it for this video. I will see you in the next one.